everybody, professor, business professionals in the area here visiting us today, fellow students, and anybody else who might be in the crowd today. Today, Team 2 is going to cover our presentation on the redesign of Polk Street and the adjacent bridge over the future 45 expansion. My name is Jose. We have Chris, Victor, Hiba, and Stevenson. So to begin, here's a quick outline of what we're going to cover today, going over all of our design considerations and hitting the key areas that we took into consideration as we move through the project. So a quick overview right now. Polk Street is a major thoroughfare. It moves from 4 lanes to 2 lanes throughout the project, and it's currently an asphalt road with off-street parking.
So for the existing cross-section, our project is on Polk Street, which is located on the Houston East downtown. So the Polk Street has 80 feet right of way. It has 2 major travel lanes, which is one goes east and the other goes on the east direction. And the road, it has 2 parking lane and 2 side walk lane. The traffic studies shows like the most traffic part is in the west direction during the morning and afternoon hours. So as a team, we decide to design a project in a way that it will be capable of multi-mode transportation. So here is our typical cross-section from bus stop to the end of the project. We will have 2 11 inches travel lanes and a 14. We will have 11 feet travel lanes and 14 feet mixed turning lane. We will have in both sides 6 feet side of bike lane and 6 feet also for sidewalk, and of course we'll add like some green. The green space will be varies between each part. So for the separate bike lane, we decide to choose this lane in order because it will be more easy in the future in order like to change like the plan. So here is the bike path cross section. So the bike path is 11 feet. We did that to conform with the Houston biking plan. So for the construction plan, regarding like the traffic study that we did last semester, so we decide like to construct like the westbound lane first, so we can use like the existing eastbound lanes and the parking lane to control the traffic. So here is our construction plan. We will construct like the westbound first, as I said. We will also change like the reinforcements concrete and stabilize subgrade from what it was in the previous. So the new one will be 11 inches of concrete and 8 inches of stabilized subgrade. For the eastbound side, we'll use this section as 2 travel lanes. 10 feet each. We'll add like double yellow between the travel lanes, and we also will add 2 inches of traffic drum in between the work zone area and the travel lanes in order like to prevent like the accidents, and it will be more safe for the workers and for the drivers. So after we finish the westbound lane, we will start with the eastbound lane. We'll use like the same. We'll apply the same procedure as what we did in the westbound lanes. So here is our demolition plan for the westbound lane, and for the next slide for the eastbound lane. We'll use like some signal traffic in order like to control like the traffic during the construction.
So let's talk about a little bit about drainage. First of all, I want to say that drainage system is a very important system. Without the drainage, the roads cannot be constructed. Drainage has to come before that, so it can convey, can take all the water, because drainage system is the system that actually takes all this water. The rainfall, the melted snow takes all this water and then, uses all these inlets, all these water pipes, and then transports this water to, bigger water resources. So what we do, how we do drainage? Well, first of all, this is our drainage area map. Before we doing this, we went to GIMS, and we found the contour maps, where are the elevations. From there, we found out the highest and lowest elevations. Since we know that our inlet should be in the lowest elevations, then this is how we start dividing our areas. So you can see that we divided into 15 sub-areas. And these sub-areas are going to have at least one inlet. The type of inlet that we're using on those areas are going to be C1 inlets according to the ADM, Chapter 9, because we're actually doing for commercial and residential. So C1 inlets are bigger and can handle more water when it talks about that. Next, actually we talk about, we did a little bit about detention, and we did inline detention because we didn't have any more space to do another detention or the normal detention. So what we did is we actually have the previous from our proposed, and then we subtracted that from the existing one, and then with that we actually have a number, and then you actually just multiply by a constant number which is given on the IDM, which is 0.5, so you can have your detention volume. From there, we start building our inline boxes, which were around, it's on our paper showing you 8x6 and 3x2. That's how we did it. This is just picture to show how the inlets are. This is C1 inlets. This is reinforced concrete pipes. So this is what we're using. One more time, we're using 24 inches for reinforced concrete pipe, RCP, and we're using also steam inlets. And the boxes, like I said, the box is going to be 8x6 and also going to be 3x2. We're going to have 2 boxes.
Alright, so as you can see here, we have a rough view of our plan sheet. It's a little legible on the current slide, but we went and upsized our sanitary and our water systems to 12-inch pipes from 8-inch, as requested by the client. We tied into the existing limits on either side of the project to keep the service going. And we did that all in accordance with the City of Houston IDM manual. To maintain, for the sanitary, we wanted to maintain the 0.26% grade through the pipe. Here's a view of our profile sheet. We also kept, for the grading, for the paving, we wanted to meet the City of Houston IDM standards, which was 0.3% throughout. We did have a section near Bastrop where our drainage area map caused us to have a 1.36% slope. So we had to insert a vertical curve at that section because that's what the City of Houston requires when there's a change over 1% in grade.
Okay, so this is our pedestrian bridge. This shows an overview of the layout. So it runs from Hamilton, Chartiers, St. Emmanuel. These green circles represent the columns underneath the ramps. Next slide, please. Okay, so this is our profile view. Our bridge consists of 3 spans. The mid span is at 220 feet, and the side spans are both 165. We also included, it's not in the drawing, but we also included a fence over the side and the top, so as to deter or stop people from throwing things over the bridge. Next slide, please. This is our plan view. So we have a 4-foot pedestrian path in the middle, so we can still be ADA compliant. We have a 3-foot bike path on either side. Our railings consist of a 1-foot area, but they run on the middle. And this is just one panel of the bridge. This panel is 11.5 feet long. This is our cross section. Pretty much the same thing as our plan view. Here's our railing. It's 4 feet and 6 inches tall. And we do have the cords going along the top and the sides as it is a truss bridge. This is our ramp view, just a general one. Our inclines are 30 feet long. We do have our horizontal 5x10 landings. We maintain the 10-foot width so we can maintain our traffic capacity. And and these are our columns for both the bridge and the ramps. So the columns for the bridge interior ones are 40 feet as to accommodate the depression for the highway. 20 feet on the sides, and the ramp columns will vary according to where they are. And this is just a general for our foundation. According to our geotech report, as well as our load calculations for each column, we decided on a 80-foot length driven pile. It will have a 2.5 foot diameter with a 1-inch thickness.
So let's talk about constructability. There are two main contract types we usually use, right? There's design bid build, which would have a designer, and a constructor. There are two separate entities. So I wanted to make the assumption that it would be a design build contract, so I'm trying to save as much money as I can while building the bridge. So the first thing you have to do is, how am I going to build this thing? Well, we're going to utilize laydown space that's available while they're making the street to pre-assemble the bridge in half sections. Then we're going to lift those sections with the crane, put them on these hydraulic lifts, and jack them into place. So this is how it works. It's pretty amazing. You go up to 60 feet and just put them in there, and they jack up. That makes the cowboy stuff. It's pretty awesome. I didn't think it could happen, but the whole point is what we're going to do is cut the spans at 220 feet at the biggest. We're going to cut it in half. You have 110 foot. We're going to utilize our crane to put it on these lifts to lift it into place. Then we'll have welders assemble it. So this is just to show an example of that this being possible. Like I said, so whenever they get up there, they're going to have the columns that are already in the ground. Then you're going to have to weld it. So we have to think how we're going to get our workers there. So we'll use man lifts and just get them up in the sky. There's plenty available. And then I want to think about the cheapest crane. So I want the classic American muscle, the Manwalk 999. It has a 250-ton capacity, and we should only be lifting about 200 tons. So, I mean, it's more than capable. It can be utilized as a pile driving rig and as a rig to actually move the bridge assembly into place. So I wanted to use, a lot of people are going to do drill piles. I want to use the hydraulic hammer because, once again, it's more affordable. So this is the Birmingham B200 hammer. It's been around since the 80s, and it rocks and rolls. So this is an example of a Birmingham hammer driving a 36-inch pile. We're going to have 30-inch piles, but just an example of how it can kill a plate. It's not an issue at all. Next slide. Then this is just showing that we're going to use full penetration welds, and we're going to utilize weld trucks. They'll have hoses so they can get their weld trucks up in the air. I also wanted to say that we have fiberglass decking, so we're going to utilize the same crane and put it in as it's shown up there. It's a pretty easy assembly per the manufacturer's instructions. Next slide. And then I just want to go into just a quick little aside about the biggest takeaway from this project to me is how difficult it is to manage a project with so many entities, and I think it could be analogous to being in industry, right? You're going to have a bunch of different firms working. You're going to have geotech coming together. You're going to have general civil. You're going to have structural. You're going to have all this coming together. And it really is, it's pretty amazing how there's little conflicts you wouldn't think about by having different entities work on things and trying to get it to mesh together, and made me realize the value of having a firm that was full service and able to complete everything. It really justified that to me in a way I didn't think was possible. So that's it for our presentation. Please give us any questions you got. Yes, ma'am.
On your lifts, that was pretty interesting. So how wide is that space and
The actual lifts themselves, they come in a variety of spaces, but they can get up to 25 feet for the actual width. And then in terms of lifting capacity, depending again on the model, you can get to over 30 meters, so 90 foot. Pretty cowboy stuff, it's awesome.
And how long does it take?
I mean, that image, I could have shown in the videos if we didn't have such a limited amount of time, but that's almost real time. Your biggest thing with that is making sure your safety's right in the pre-treks before, but I mean, I have no doubt issuing the fact that you could have the crane get one on each pile of the day. You know, I don't see it being an issue. That was part of the justification of that is you can't close the road for a long time, right? People in Houston don't want to drive. That's just how it is. So I think that with that technique, you can expedite the assembly, and then prefabbing on the side and moving it into place will again just reduce the impact on road usage. Yes, sir.
It appeared that the demolition plan was only curb to curb. It didn't look like it accounted for the driveways and anything else back from curb to edge of driveway.
Yes, sir. We do plan to replace the driveways up to the end returns. I do not know if our demolition plan did not reflect that as an error on our part, but we did account for that in our proposed that we would replace up to the end returns, and we graded it appropriately so we would maintain the water in the right of way.
You talk about the drainage, can we look at the drainage map? The drainage area map? I wanna make sure I saw what I saw. Yeah, so it looks like the drainage area map is taking a large section across Bastrop, is that right? Is that what I'm looking at?
What? Go ahead, sir.
Like, so you have these
You're
four- you
saying
have
why
these
there's the
four-
extended one?
Yeah, you have the extended drainage area that goes from Hutchins all the way between Bastrop and Emancipation. Am I looking at that right?
Yeah, the justification for that is the road in the middle isn't paved. We don't intend to pave it, so we couldn't put inlets there. We put inlets on each in return, and we actually put more inlets than probably are required or seen at other places just to try to reduce ponding. And that is the one location where we have a steeper street grade. But again, I have C1 inlets on all four corners over there. To the right where we just have the boxes, that's existing, and for budgetary reasons, we left that existing, so I just left it how it was.
So did you consider, instead of having that long run along the right of way, say for example, that far corner there between Bastrop and Emancipation, instead of running all down the right of way to Hutchins, did you consider splitting that area to take it to Polk instead of what you're showing?
No, sir. The only other thing I considered was on-grade inlets, but I didn't want to run the pipe out that far. Yes, sir.
You said you had 80-foot piles for the pedestrian bridge?
120-foot piles.
120 feet. Is that like a round structure?
That's going to be within the highway improvement plan. So I know a lot of people have issues with, hey, what's the vibration going to do to the surrounding utilities? They're already tearing up all that street. Now we would say we would probably want a geotech firm to do a vibration analysis, but at this point we do not have that information. In my opinion, it wouldn't affect it, but until I have numbers behind it, I wouldn't put my name on it.
Are those piles going to interfere with the new underground highway that they're putting in there?
I wouldn't believe so, sir, because our placement, like we have if you go, hold on, over there, you're going to have two ramps, and then you're going to have two places with piles, two pile locations, and those are in between lanes. So I would not think it would do that, because that's why we specified where to put the pile, like the column locations. So it's just that I do not have their plans to compare against, so I don't have a definitive answer. Yes, sir.
Going back to drainage, walk me through again how you sized your box culverts in order to accommodate the detention, and what sizes were they again?
So, sir, what we did was we took the existing impervious cover and we deducted that from our proposed impervious cover, and then we chimed that delta by the number figured in the IDM, which is 0.5. That gave us acre feet. We then converted that to foot cube. From there, we sized the detention accordingly to that. We do have a very large 8x6 detention box at the very end, but that's because we wanted to slow the flow because we don't know how our outflow is going to affect the existing bridge system.
That's a follow-up question. How are you making your connection to the where and how are you making the connection to your existing storm sewer
At the
system?
existing, we were going to add a manhole at that location.
A manhole.
Yes, sir.
And which pipe were you connecting to?
I believe it is a 42-inch RCP. I'd have to look at my plans again to get
Are they the one in Charters running north-south?
Yes, on Charters. Yes, sir.
Okay.
Yes, ma'am.
You guys said you upgraded the sanitary sewer.
Yes.
How did you guys connect to existing?
We just use TS and Bs. I'm hoping that works with sanitary, it works with water. So taps leave valve.
Since one was a 10-inch running through San Emmanuel, did you guys connect to that 10-inch?
We did.
Upgraded it to 12?
We did not upgrade it to 12, so it's 12 going into 10, but that's what we did. We used the TS and B.
On your sanitary sewer, where was your point of connection to the main system, the existing system? For sanitary sewer, point of connection?
We'd have to look at our plans again, sir. I think we reused some of the, yeah. I don't think we have it on the plans that we show here.
Okay.
We can gladly get you that answer after our presentation.
I'll look at your plan.
Yes, sir.
Did you guys confirm that with your, I think it was an 806 box that you had after the tip, with that box, and that your HGL would allow you to utilize the full volume of the top of that box?
Yes, we did confirm that we would maintain the correct amount of cover from top of pavement to the top of that box. And then we put it at the end of the system, so that's after all the sloping going down. I'm not gonna lie to you, I didn't confirm the HGL. Whenever I put it in the storm calcs that were like the Excel spreadsheet requirements to get an idea, when I put it in that, it said it was rocking and rolling, so, but I'm not gonna tell you I confirmed something I didn't. Yes. You never have quick questions.
How do you connect your columns when you work together? You said you have your columns, and you're gonna jack your.
We're gonna have the columns that are existing, right? Then we're gonna build the bridge in 2 phases. We're gonna jack them up right next to it. We're gonna use the manual to move it to have 5, however many feet to put it atop the column. From there, we will weld it. Yes, ma'am.
Now, how do you connect the piece to the
It's
column?
full penetration weld. You're gonna have to have some type of concrete box at the top for us to sit on. We haven't designed that far out yet, but you're gonna have to use a weld that you know that no matter what, the joint isn't gonna be the weakest issue, it's gonna be the member. So full penetration weld is probably 1 inch.
And do you reinforce steel with your columns? Do you have the dot for reinforced steel with your columns?
We would, yes. I mean, I believe that the columns we're using are steel columns, and that's what we're gonna drive in the ground, right? Because you can't drive a concrete column, but there's gonna be, maybe I'm misspeaking, we're gonna use steel piles and we're gonna have a concrete column, and yes, the concrete is designed.
And you find the wind is very hard to weld. How can you know that your weld will be accommodated?
Well, we could say that things are hard all the time, but I mean, there are many oil and gas jobs where they weld way higher than that, and you just work around the weather. You can build tents. I mean, there's a wide variety of approaches you can use to get that job done.
Okay, one more question. Anyone?
How are y'all feeling?
That was it. Yes, sir.
I don't have a question, I have a comment. I think that the flow of the presentation was really good. I have to say that we came out, especially at the end when you are presenting how you're going to do it. It's not only doing it, but also thinking of how it's going to be the building process. You guys explained it pretty well that section. And another comment that I'm going to do now before the other things, because I think that having only one member taking the questions is not fair. So I think it seems that the rest of the group didn't do much. So you guys need to step up whenever the question comes to have a little more of a distributed answer. And I hope the next teams do exactly the same. Thank you guys.